Hello! In this video, we present the retrosynthesis of Erdafitinib, a drug used in the treatment of certain types of cancer. In general, we can say that this retrosynthesis leads to three key precursors that in turn come from accessible raw materials, as we will see later on. The tertiary amino group in 1 acts as a retrone and a carbon-nitrogen disconnection. Based on a nucleophilic substitution, it produces aniline 2 as a precursor and chlorothalonine 3 as a raw material. The amino group in 2 acts as a retrone and a second carbon-nitrogen disconnection, based on a Buchwald-Hartwig reaction, leads to the brominated quinoxylin 4 and aniline 5. The pyrazole ring can be attached to the quinoxylene ring using a Suzuki-type cross-coupling. With this idea, a carbon-carbon disconnection in 4 generates the dehalogenated quinoxylene 6 and the boronate 7. A functional group transformation converts 6 into hydroxyquinoxylin 8, which has compound 9 as one of its tautomeric isomers. The lactam group in 9 acts as a retrone, and based on an intramolecular amidation reaction, a carbon-nitrogen disconnection generates compound 10. The amino group in 10 now functions as a retron, and a carbon double bond nitrogen disconnection gives rise to orthophenyladiamine 11 and ethyl oxoacetate 12 as raw material. Considering an aromatic bromination, a carbon-bromine disconnection is applied to generate phenylenediamine 13 as a raw material. The boronate group in 7, attached to the pyrazole heterocycle, can be incorporated through a coupling between bromopyrazole 14 and chloroboronate 15, which arises as a raw material. Based on an aromatic bromination, a carbon-bromine disconnection at 14 leads to N-methylpyrazole 16, where a carbon-nitrogen disconnection generates pyrazole 17 and methyl iodide as starting materials. Based on a Schmidt-type rearrangement, aniline 5 generates the substituted benzoic acid 19. The methyl ether groups in 19 function as a retrone, and 2 carbon-oxygen disconnections give rise to benzoic acid 20 and methyl iodide, both as raw materials. In summary, the main disconnections are shown here. The resulting synthesis will be presented in the next video.